Grandpa Ruby, I love that. Jim Wyrick. If you use Bundler and Rake, you've used some of his tools. You may or may not know that he also is a ukulele player. And was, rest in peace, Jim. He wrote a song called Has Anybody Seen My Code? And it was kind of his like ode to Ruby and Java. And you gotta be careful when you write a song that references languages, because languages come and go, and hopefully between Ruby and Java, at least one of them will be out of style soon. There you go. So I updated the lyrics to this song, and I hope I fit it in the time allotted. It's called Has Anybody Seen This Code? Doing audio syncing for the first time. This is amazing. Variables named randomly, far too much complexity. Has anybody seen this code? Functions long, all impure, steaming pile of horse manure. Has anybody seen this code? If you should get the urge to write code like this, wronger than sin. Don't be a fool, go back to school and learn some discipline. It's leaking scope constantly, it's not so SOLID. Has anybody seen this code? Segmentation faults, la 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 la, no method error. La 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 la, 404 not found. La 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 la, cannot eject. If you should get the urge to write code like this, wronger than sin. Don't be a fool, go back to school and learn some discipline. Well, I check the blame, I see my name. Oh shit, well, it's all the same. Has anybody seen this code? La da 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 da, the reference exception. La 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 la, the blue screen of death. La 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 la, certificate not trusted. PC load letter, what does it mean? It's leaking scope constantly, it's not so SOLID. Has anybody seen this code? Variables named randomly, far too much complexity. Has anybody seen it? I hope nobody's seen it. Has anybody seen my code? Wow, wow. Thank you.
Excellent, excellent.
I have a few seconds left. On a more serious note, this is, video out, video back. This is my mom and I. And when I was born to a single mom in Chicago in 1975, the odds against my getting a college education, a computer science education, and getting a job in this field seemed pretty long. But thankfully, with the work of Jim Wyrick and a lot of other great organizations and charities, it's becoming a possibility for more people. So guys, get out and donate or help the cause. Thanks.
Thank you.
Question? Who has to estimate software? Raise your hand if you have to do estimates. Software, projects, features, whatever. Okay, keep your hand up if you like it. Okay, I envy those who still keep their hands up. I don't like it. I think it's difficult, it's boring, it's time consuming. What's more, there's sometimes this specific client perspective to estimates. But that's not the worst. The worst about estimates, which we usually do, which are based on expert guesses, is that they usually just don't work. And that's because of many things. One of them is the planning fallacy, which is a research-backed theory saying that we as humans are just bad at estimating. We constantly underestimate time for tasks despite our previous experience, that it just took longer. So let's face it, we suck at estimating. My name is Tomek Grusiłko, I work in Lunar Logic, and I suck at estimating. So in Lunar, we've decided to stop this nonsense and try something else, try something different, and we've come up with this, well, we didn't come up with it, but we started using this idea of data-driven estimation, statistical forecasting. And I want to quickly show you how this works. It's a really simple concept. Actually, it's so simple you won't believe me that it works, but let me try anyway. We are going to estimate an ongoing project, a second sprint of the project, and we are going to estimate 10 stories. Since it's data-driven estimation, we need some historical data, so we're going to use data from the first sprint of the same project with the same team. And this data looks like this. This is all we need to do a statistical estimate, statistical forecast. This is just 5 stories, and their start and end dates. And let's put it in a timeline. It looks like this. And there are 2 things we can get from this timeline. One is the lead times, which are just lengths of those stories, those tasks in days, and let's write them down. And the second thing is work in progress values, which is just how many tasks were done concurrently on a given day. Those are the purple numbers. Let's write them down too. And remember, we want to estimate another 10 stories. That's what our client wants. So what we're going to do is we're going to run simulations. And this is how one simulation looks like. We're going to take our pool of lead times and just randomly draw 10 of them for each story we have to do. And then we're going to sum them up to 28 story points. And then we're going to do similar thing to our work in progress pool of values. We're going to simulate a project day by day, drawing one of those values for every day until the sum of them reaches at least 28. So this means that in this particular simulation, we actually needed 15 days to finish up our 10 stories. But that's just one simulation. So then we repeat it 10,000 times. And we get different values of those days, the number of days. So we can put it on a histogram with, we have days on the x-axis and the number of those numbers on the y-axis. And then we can find where is the day where 50% of those simulations ended, and in this case this will be 12. And we can do another threshold like this for the 90% of our simulations, which is 14 days, which essentially translates to our confidence levels. So what we're going to tell to our client is that we are 90% sure that we can finish those 10 stories in 14 days. And we are 50% sure that we can finish in 12 days. So we're going to be wrong one out of 2 times, right? And then we just put it on a nice timeline graph like this. And this is what we use. We don't do expert guessing anymore. We use this tool. And you can use it too. It's called Projector. You can use it for free. It's just a simple app, and you can upload your data there, just start and end dates, and you will get those estimates. So this is it. If you want to read more about this concept, you can visit our blog at lunarlogic.io. There is a long post going into more detail about this. So just stop guessing, start using data. Thank you.
I'm going to be talking to you guys about how feminism has made me a better engineering manager. I have 5 minutes, go. So I want to talk to you guys a little bit about feminism, and it's kind of a big word, so I'm going to focus it down a little bit because Feminism as a concept actually is a little bit ambiguous, and it encompasses a few different things. There's a political movement, there's an academic and philosophical movement, and there's also a lot of overlaps with kind of similar movements that are a little bit differently focused. For example, the civil rights movement. And there's intersectional feminism that tries to kind of pull all of those things into feminism as well. And I personally tend to focus more on the philosophical and academic side, and admittedly a little less on the political side. So my point of view is kind of an oversimplification of what feminism is. So take my definitions, with a grain of salt and whatnot. But for me, what feminism is, like why I'm super interested in it, is because it takes what is generally implicit cultural assumptions and it tries them out and it tries to make them explicit and to talk about how it affects people and how it creates power imbalances, and especially in a gendered way, and how culture kind of sucks and helps us acknowledge it, and by doing so helps us be able to rectify it and change it and make it better. So that's kind of what keeps drawing me back to feminism as a really interesting topic. And the reason I'm up here today to talk about it is because I want to take that point of view and lens and apply it to how we think about managing people and our relationship and social ties in a work environment. Because I do think we pull in a lot of implicit cultural assumptions and cultural baggage into work, and a lot of those assumptions end up hurting us, end up hurting your employees, end up hurting your managers. And I really, a core theme of feminism is, in my mind, and I think I'm stealing this from either Judith Butler or Audre Lorde, is the study of how to make life more livable and fulfilling for more and more people. And I think studying a work environment and trying to make it better is definitely a noble goal, to try to make people's life more livable and more fulfilling. So I kind of want to mention a few concepts and want to talk about them a little bit. Might run out of time, but that's fine. The role of a manager is to tell you what to do. Is an assumption that a lot of people bring into the workplace. And especially in creative work and the work that we do every day, it's actually kind of bullshit because your manager isn't in the code with you. They don't really know what you need to do to ship the feature, whether you need to stop to refactor. There's a lot of creative energy that you bring. And the core assumption that the manager's job is to tell you what to do actually is flawed. There's also this concept many of us have heard or talked about before, that's like the manager is supposed to be the meat shield or the shit umbrella for the team, right? They go to all the meetings and talk to all the other people, and they protect the team under them to let them actually focus on work. And I think that point of view is also pretty destructive because it creates this adversarial relationship and assumption between your team and the rest of the company, your team and the clients. And I think that's really damaging to our work environment. There's also concepts such as an individual's primary job is to build features and ship code. And yes, that's true. Like, our job is to build features and ship code. But I think our job is also to learn, and it's to level up, and it's to get better at the craft of software over time. Because, and I can say as somebody who's managed people, if somebody takes a week and doesn't ship anything but really levels up on Ruby on Rails, like digs into a bug and fixes it and really understands a feature of Ruby on Rails, the benefit of that to the team over the next year of them being able to mentor people and guide people through it is so much bigger than if they spent that week just shipping code without stopping to learn. And so I want to make all of those assumptions explicit. I want us to start talking about them. I really want to air them out and talk about what really should apply and what shouldn't, and how we can make our relationships to each other in the workplace much better, much more effective to what we actually want to get out of it, which at the end of the day is creating value in the world for ourselves and for other people around us. Thank you.
All right, so I'm going to try to talk about the CAP theorem in 5 minutes. And the reason I'm talking about this is I think hopefully I can explain it in 5 minutes. And also because I think a lot of tech terms are wrapped in these technical terms that when people hear them, they kind of get put off by them and don't try to understand the underlying concepts, right? So we don't call it passing stuff into stuff, we call it dependency injection. We don't call it inheritance, we call it Liskov substitution principle, right? I think this is one of these things that is important if you use any database to understand the principle, but I think it is wrapped in this thing like a theorem and people get scared off. So I'm gonna try to explain it to you in 5 minutes, see how I do. So basically it says if you have a distributed system, your network will fail at some point, and so you have to make trade-offs between consistency of your data and availability. Again, that probably doesn't mean much, so let's take some examples. So this is kind of your first version of an app, right? You usually have multiple threads or multiple processes accessing one database, right? You write something into the database, and you can read it out, and it's pretty easy. So you have a lot of consistency there, because you put data in, and you get it back out, and you don't have any problems with data consistency. But the problem with this is that if this database goes down, your whole app goes down. So your availability is way down, your consistency is way up. So what a lot of people do is they have app v2. They say, well, we don't like it that we have this single point of failure where we have this database that goes down and our whole site goes down. So what do? They have a replica, right? So you write into your main database. That sends it over to the replica database, which then you can now read it from this other Rails process. Now, that is really cool because if this database goes down, only part of your app goes down, and you can now still continue to read as if that didn't happen, right? So now your availability has gone up, but now we can see it's actually going to make our consistency go down a little bit more. So availability is up, but what happens again if this connection between your database and replica goes down? Well, now when you read, now you have no idea that that data does not exist anymore, right? So the consistency of your data has gone down even though your availability has gone up. And this really goes for any sort of topology you can think of, right? So we can have super complicated databases, we can do super complicated schemes, but in general, you're gonna make a trade-off between the consistency of your data and the availability of your app, right? So let's say you have a super distributed DB, right? So let's say you have something like, you write something into it, there's this routing layer, there's this amazing routing layer, it knows, great, here's a piece of data, I'm gonna go put it in this database over here, and this database says, cool, I got this data, I'm gonna go spread it out to all these other databases, so now you have all these different copies of the data, right? And now when this one comes and reads, it goes to routing layer says, cool, I can read from any one of these databases because this database has the information, right? And now you get it back. This is really great for availability, right? Because we can have a bunch of things go down and it still kind of works, right? But of course now with all these different connections, now again, our availability went up, but now we have all these different connections where the consistency of our data could go wrong, right? This one could go down, that means now we have inconsistent data in that database, or this one could go down, or all three of them could go down, and now you have one database that has different information than the other databases, right? And that's pretty much the CAP theorem. I mean, that's all it is. You can think of every different topology that can come into your head, and that's really all it is, right? It's just a trade-off between consistency and availability. So you can imagine if you're running a bank, you don't want to have a super distributed database because when you put money into your bank, you want to read that and it come out right away. You don't want to put money into that bank and then the sync goes wrong and then you say, cool, where's my money? And your database goes, shrug, I don't know, right? So again, this holds for any topology, and pick which database is important for you to do whatever job that you're doing. Thanks. And so I'm also at Reverb, and my CTO would probably admonish me if I didn't say that if you're interested in Ruby, Elasticsearch, Go, React, Redis, any other cool hip things that I didn't say that we use, please go talk to anyone with a Reverb shirt on. Thanks.